So the purpose of this workshop is to provide you a quick update on that release. At the end of this workshop, we hope you will have a clearer picture of the main features and the updates of our latest and greatest LeapBridge Concrete. Here is our agenda today. I will go through the main features as shown below. For the latest LeapBridge Concrete, it supports two recent versions of Ashton LRFT code. It supports the LRFT 7th edition with 2016 terrain. It offers the lightweight concrete design in both superstructure and substructure modules. Also, it offers an option to use the effective footing dimensions for the spread footing as per LRFT Section 10. It supports the quantities of wing walls. Also, it adds totally 23 new Virginia DOT standard beam types into the library for precast and pre-stressed girder design. Then I'll briefly show you a demo about the main feature, the new wind load per the latest LRFT. At the end, we will have the Q&A session. We have received users' requests from time to time to support the multiple versions of LRFT code. In reality, the practice of adopting the latest design code typically falls behind. So after our careful evaluation to address a user's needs and to balance the maintenance challenge for our product, we made a decision that LeapBridge Concrete will start to support two recent versions of LRFT code. The first one is the LRFT 7th edition with 2016 terrain. This is the latest and greatest LRFT code. I will refer this version as the new code in my following talk. The other version of the LRFT code is the LRFT 7th edition with 2015 interim. Similarly, I will refer this version as the old code in my following talk. This screenshot shows you the options for the two versions of LRFT under the product manual of design code in the precast and the pre-stressed girder module. This picture shows the two options in the cast-in-place reinforced concrete post-tension girder module in LeapBridge Concrete. This screenshot shows where to select those two options in substructure module. Speaking of the latest version of LRFT, it includes two major changes compared to the previous version of LRFT. The first one is the new wind load. I provided the reference article number here also. The second major change is a lightweight aggregate concrete design. I'll elaborate on those two in the following slides. In addition, there are a couple of other minor changes in the new code. The first one is the live load factor of the service 3 limit states. Basically, it adds a new live load factor for the situation when the refined method of the time-dependent losses is used. The second minor change is the parameter in control of cracking. Basically, it puts a limit for the thickness of the concrete for calculation purposes. By doing that, it eliminates the confusion of getting unrealistic results of the required spacing for the mild steel reinforcement in order to satisfy the cracking control per LRFT. The third minor change is the allowable compression stresses before losses. Basically, it allows slightly higher compression stresses before losses. There are significant changes regarding the wind node generation per the new code. First of all, the design logic changes. The old code specified the basic wind pressure based on 100 mph wind speed. Then the design wind pressure is adjusted based on the actual wind speed, and the wind pressures acting on the superstructure and substructure are calculated accordingly. The new code completely gets rid of that approach to modify the basic wind pressure. Instead, it offers a new approach to calculate the wind pressure. These changes can be summarized as the following 6 aspects. The new wind load introduces a new wind exposure, some new parameters to calculate the wind pressure. It also has different horizontal wind pressure, different vertical wind pressure, different wind load factors, and different load combinations. I'll elaborate on them one by one and also show you how those changes are implemented in our OpenBridge concrete product. For wind exposure, the old code simply uses the bridge locations as highlighted here. The new code uses the wind exposure category as a B, C, and D, which are actually dependent on the ground roughness categories. It's highlighted here. You have a pull-down menu. I will show you that in the demo. The old code uses default wind pressure. It's highlighted here. You can see there. The new code provides a more comprehensive procedure to calculate the wind pressure. It introduces more parameters such as the drag coefficient, C sub D for superstructure and substructure, the pressure exposure and elevation coefficient, K sub Z for different limit states, which is actually depended on the wind exposure category here and the structure height Z here. Also introduce the gas effect factor G here and the 3-second gust wind speed for different limit states as shown here. Regarding the different horizontal wind pressure, the old code uses just one design wind pressure for all wind-related limit states. However, in the new code, for different limit states, the calculation procedure are different. For example, it used one procedure for strength 3 and service 4, and use another procedure for strength 5 and service 1. Speaking of the different vertical wind pressure for overturning check, the old code uses just one design wind pressures for various limit states, as highlighted here. The new code uses different design wind pressure for the corresponding limit states. As highlighted here, for strength 3, it uses 20 psf per square feet. And for service 1, for example, in this case, use 10 psf. The new code has the new load factors for wind load on structure. For strength 3, strength 5, service 1, service 4, you can see the change of the load factor here as highlighted. Let's take a look at a typical example of an auto-generated wind load combination involving wind load. On the left side, it shows the results per the old code. For one wind attacking angle, here is 0. The old code generates just one wind load cases. Here is a WS1. And this one wind load cases subsequently is used to generate all limit states involving wind load, as you can see here, this side. This is the results generated by the new code. For one wind attacking angle, the same wind attacking angle is 0 here. The new code will generate 4 different wind load cases. One for strength 3, one for service 4, one for strength 5, one for service 1. So for one wind, and each of these 4 wind load cases is used to generate just one corresponding limit states only. You can see here. This load case WS1, because it's for strength 3, so it only shows up in strength 3. And so on. WS4 is generated particularly for service 1, so it only shows up in the load combination for service 1 here. So that's a big difference, how the node combination generated per the old code versus new code. Another major change in the new code is considerable changes have been made in the new code regarding the lightweight concrete design. These changes include a new definition of lightweight concrete, a new parameter, which is a concrete density modification factor lambda, has been introduced in the new code. The lambda factor has impact on the following design aspects, including the modulus of rupture, minimum transverse reinforcement, nominal shear resistance, simplified procedure for pre-stressed and non-pre-stressed sections, and shear torsion resistance factor, a modified tension development length, a basic hook development length. For the definition of the lightweight concrete, the new code basically consolidates the previous two lightweight concrete types into one. You see, previously it has a category of all lightweight concrete and the sand-weight concrete. Now you only have the lightweight concrete. For the lambda factor, here, there are two approaches to calculate it. Our OpenBridge concrete uses the second one as highlighted here. And the lambda factor is a function of the unit weight. For lightweight concrete, typically the lambda factor is between 0.75 and 1.0. For normal concrete, lambda factor is 1. Comparing to the old code, the changes made to the design aspects are that lambda factor is added into the related formulas as specified in the old code. So in that case, the lightweight and the normal weight concrete can share the unified formula in the design. This shows the changes in the new code to the modulus of rupture. You can see lambda factor is just added into the specific formulas. And this shows a change to the shear and the torsion resistance factor. So the lightweight concrete use a different resistance factor now. This shows similar to the modulus of rupture, a few more changes incorporating the lambda factor has been done, including this shows the minimum transverse reinforcement. So you can see the lambda factor is just added in compared to the old code. Also for the nominal shear resistance, lambda factor added to the shear capacity from the concrete and the shear capacity from the steel. Lambda factor added. And this shows the changes of the lambda factor added to the simplified procedure for pre-stressed and the non-pre-stressed sections. There are a couple more. This shows the changes of the modified tension development length. So the lambda factor added here. You can see clearly here. And this is changes made to the basic hook development length. Lambda factor also added accordingly. So again, the lightweight and the normal weight concrete can share the unified formula in the design. We implemented the lightweight concrete design in both superstructure and substructure modules. This screen shows where to choose these lightweight and normal weight concrete options in substructure module. This gives you the screenshot to show where to select the lightweight or normal weight concrete in the casting place, reinforced concrete, or post-tension girder module. This screenshot shows you where to set up the lightweight and normal weight concrete in precast pre-stressed girder module. In summary, once the concrete type is selected or determined based on the unit weight of concrete, then the lambda factor can be either auto-calculated or manual input. So those the design aspect we just mentioned a moment ago, based on the lambda factor, are automatically calculated internally in LeapBridge Concrete for the corresponding design check. In LeapBridge Concrete, traditionally, the soil pressure under spread footing is calculated based on the assumptions. One is the footing is a rigid body and rotate with respect to the center of gravity of the cap. Another assumption is the soil pressure is linear distributed underneath the footing cap. At the request from our users, we implemented the feature to use effective footing dimensions as per LRFT section 10. So this is only applicable to spread footing on soil. The idea is to use the reduced effective footing area and the related uniform soil pressure in the spread footing design. So how to get this effective footing dimensions? So what's the impact on the soil pressure underneath? So how we calculated that? Here are the basic steps. So step one, we can start with getting the load effects in terms of the vertical load, transverse and the longitudinal moments at the center of gravity of footing cap. The LeapBridge concrete will generate those load effects automatically. Step two, to obtain the point of the node application. Basically, to move the vertical load P to the point where the load effects on that cap remain the same, but the both longitudinal and transverse moments are zero at that point. Step three, calculate the eccentricity in both transverse and longitudinal directions. So you can see the eccentricity here. And based on that point of load application, and calculate the uniform, the last step would be calculate the uniform bearing stress based on this load P here and the reduced area here as you can see in the shadow area here. Also, in deep bridge concrete, it offers an option under the footing tab here. In 80 parameters, a user can check the box for effective footing dimensions here. So if this box is unchecked, the soil pressure will be calculated in a traditional way, as mentioned previously. So when this box checks, so this is a result showing the calculated the uniform soil pressure. You can see here only P reported here, and at that location, the moment in transverse and longitudinal direction reported 0. And the governing, also the governing case, you can see here under the column of combination, and the corresponding soil pressure reported here. Deep bridge concrete offers the modeling of wing walls through the ABC wizard. Currently, deep bridge concrete does not support the structure design for wing wall yet. This feature has been on our future development list. However, we decided to add these quantities of wing walls, so our user can take advantage of the feature in the preliminary design of bridges with wing walls, and quickly come up with an estimate of quantities and related cost, if a unit price of the quantities are also provided. Here is an example of a report. So this is a report for the substructure quantities. This is showing the quantities and the cost of wing walls for the beginning and end band, abutment 1, abutment 2 here, together with other substructure components, also with piers. So you can see the concrete, the quantities showing here, and if we provide the unit price, it also automatically come up with the estimate of the cost. We also added new Virginia DOT beam types and support them in the modeling, analyzing, and design in deep bridge concrete. They include line bob T beam section here. You can see here 6 voided slab here in the library, and 8 box beam here. All right. In the following couple of minutes, I'm going to show you a demo about the new wind node generation. Let me bring up the bridge. In order to save time, I just use the ABC wizard to build this concrete 2-span concrete bridge model. So then I go to the substructure, activate the substructure module. So in the design code here, we can see we have 2 versions. One is for LRFT, one is 2015, interim, one is for 2016 interim. Let's check the latest design code. Let's go to the node generation. So we want to generate some wind node here. So this is wind node on structure. Select. So we highlighted it and click the edit. So it pop up the window of the node data. And we want to do the auto generation here. Click the auto generation. So for the wind attacking angle, we just, for illustration purposes, we just click 0 here. So this is a new added the wind exposure category. So we can choose it's C. Then we input the response the other field in other input fields. This is for the elevation and the C sub D for superstructure, substructure, and this is another some parameters for different limit states. This is based on automatically calculated based on the wind exposure categories. So we can use this as a default. We can change also if a user want to change it, so we can change it, override these values as well. If we want, include at the bottom part. So if we can see the auto-generated the wind pressures for strength 3 shows the wind pressure here. For service 4 shows generated the pressure here, and so on for strength 5, service 1. This is for the horizontal. If we want to consider the overturning, consider the vertical wind pressure, we check this box, and we can use the default. If this is unchecked, the default is value is calculated here. But if we want to override the program calculated the value there, so we can check this box and override it. So let's just use the default values there and click generation. Then it will generate the wind node. This is this portion part shows the wind node at the bearing locations. And this shows the wind load in the column, and this shows the wind load in the cap. We click. So you can see here for the one wind attacking angle, 0 degree. So we will generate the 4 different wind load cases for 4 different limit states. Then let's do the node combination generation. So we choose, let's to simplify that, choose here strength 3, service 4, strength 5, service 1. Click the load combination button. Then we can use the default combination. Then it automatically generated. In this case, I do not include any other node types, just the wind load cases. So you can clearly see so which wind load case goes into which node combinations. I think that concludes my brief demo here for the new wind node generation. And Let me bring back my presentation slides. All right. I think that's thank you for your attending, and I'm now we are open for the Q&A session. Sheree?
Yeah, thank you, Shane. Thank you
Mhm.
for the presentation. So the main part of the workshop is now over. Here, opening the meeting for asking any question. There are already a couple of them there. Um, so there was one from Danny. Danny, yes,
Okay.
this kind of input method is available in RCPR. As I said in my response there, this was done specifically for Iowa DOT, but all can use this feature. And to know the exact format, please refer to the user manual in for RCPR. There's another question on OpenBridge Modeler. What's new in OpenBridge Modeler? The OpenBridge Modeler was recently released, only last week it was released. Please go to the B communities and look for information on what is included in the latest release. Several new features have been added. Specifically, we now offer automatic generation of a couple of drawings in DGN for abutments and piers. Um, Another question from Rafin, do you have any jumping on me? Do you have any option to choose HS or H loading in Leap Bridge beside HL93 to check existing bridge? Yes, Leap Bridge concrete is pretty versatile in terms of the specifying live loads. All sorts of truck configurations can be specified in Leap Bridge concrete. So yes, H and HS trucks can easily be specified. In fact, they are already there in the library. It's simply a matter of pulling them up and adding them to the project. Um, do we still need the RCPR when you have the Lee Bridge concrete? Michael, no. The new Lee Bridge concrete, the recently consolidated Lee Bridge concrete, includes all of our older components, which include Geomath, Conspan, RCPR, Conbox, and even the standalone version of Consplice is now included in the Lee Bridge concrete subscription. Uh, Next question from Jeff. Will more state standards, for example, girder types, design preference, etc., be included moving forward? Jeff, yes, we continuously do that upon request specifically from the DOTs. Um, Leverage Concrete in general offers so many user preferences that many times you can get away by simply using those to conform to specific state needs. However, if there are peculiar requirements that cannot be met by those user preferences we already offer, and a state DOT requests that, we we do offer that. So we are, for example, we are doing something specific to Florida DOT now, and Caltrans amendments are automatically updated in Leverage Concrete. But as time goes on, we will offer and add more state-specific requirements upon request. What if our case not needed service 4 combination since Leap is creating service 4 by default? Uh, Yusuf, you can always either use the default combinations or simply ignore them. So, for example, in RCPR, all of the combinations are listed on the left hand side, and it is up to you to move whichever ones you need to the right hand side, and only those will be included in the analysis and design. So you don't have to use service 4 if you don't want to. Question from Danny. Iowa DOT allows input via text file. How about copying directly from Excel tables and pasting into leap tables. Uh, Danny, that's a very good suggestion. We will consider that in future, but for now, we only offer the text input. Thank you for a great suggestion. Jim, thank you. Your comment, great improvement on footing pressure on soil. Is there any plan to address similar solution for footing on rock? Yeah, this was our first attempt to do this for rock, and we will uh, offer all the other options as well. Thank you, Jim. Another question by Moshe Kohn. Is there a way to export from LeBridge concrete in Excel format? Yes, all of our output from LeBridge concrete can be exported into Excel or PDF or Word formats. Mustafa, does LeBridge has Arima in it? Uh, Mustafa, we don't support the Arima design code. However, the Arima E80 loading can be specified in LeBridge concrete. So you can analyze the structure for the Arima loading, E80 loading, Cooper E80. However, the design is done, performed only according to either LFD or LRFT. Did I miss any questions here? Not really. We still have some more time, so I'll wait. There's one more that just came in. For DS design, ask input for K value spring constant. Soil report does not have those values. Where can we have those in order to have them as input? That is an interesting question, which typically means I don't know the answer. Sorry, Arfin, but yeah, no, those spring coefficients you really need to come up with on your own, and geotechnical engineers will basically typically will provide that input. So I understood live load impact is not calculated if you use a remote train, right? That is right, Mustafa. All we have is the loading, the axle loading, the long train of axles. But you can specify the impact factor. Right, I see a few more are coming in. In the meantime, let me just make a couple of announcements. The next SIG workshop will be on March 9. The topic for that workshop is bridge interop with open roads. This is about how you can reuse the alignment, profile, and ground information from open roads into our bridge applications, namely Lee Bridge Concrete, Lee Bridge Steel, and RM Bridge. So please look out for that invite. Next SIG workshop on March 9. Question from DP Chandra. Do you have plans to consider interaction of adjacent structure units, piers or abutments specifically for longitudinal loads? Um, DP, yeah, this question does come up. For now, what we deal with is only one bridge at a time. So if you're two different structures side by side, and if you're talking about um, interaction between the two, we really do not consider that. We might do that in future, but for now, really, we are limiting uh, to only one structure at a time in Lee Bridge concrete and also in Lee Bridge steel. Um, Patsy is asking, how do users update their Lee Bridge concrete to get the latest version? Well, that's very easy. You go to Bentley Select and look for the latest version of LeBridge Concrete. In fact, we only post two latest versions of all of our bridge products on Bentley Select. So just look in the search box, type in LeBridge Concrete, and you will find two versions. Download the latest one. DP Chandra is asking, I was talking about adjacent piers within one bridge. Yes, that question has come up several times. So if one bridge superstructure is supported by two separate piers, I think that is what you're referring to. That is something that we constantly get requests on, and DP, yes, we are considering to address that need in one of our future versions of LeBridge Concrete. As you can imagine, there is a long list of enhancements, and we basically prioritize those and offer them as they come up through the priority. But this is pretty high on the list, and yes, one of these days we will be doing something about it. Thanks, DP. It looks like the question, the pouring of questions is slowing down. So in the meantime, let me make my second announcement, and this is about the PCI Convention. This year's PCI Convention and the National Bridge Conference will be held from February 28th through March 4th in Cleveland, Ohio. I don't know why they picked Cleveland in February, but anyway, that's where it is. Although it may be cold, the conference is going to be very exciting. It always is. PCI conferences are great. It will feature several education sessions as well as lots of bridge committees, including the main bridge committee, bridge producers committee, and also ASHTO's T10 committee on concrete bridges will be meeting at PCI. I will be chairing the LRFD subcommittee meeting on Thursday, March 2nd. So please plan on attending the meeting to discuss and share your experiences and any suggestions you may have for improving the LRFD specifications. So looks like we are coming to an end. I don't see any other questions. Did I miss anything, Patsy, Shin? I covered
I,
almost all of the
yeah, I think we
questions.
covered more.
Okay. All right. So please, again, thank you for attending today's workshop. And if you didn't get a chance to ask the question now, or if you come up with questions later, feel free to contact Shin or me. I'll put our email addresses in the window here. Contact either Shin, the product manager for LeBridge Concrete, or myself with any questions you may come up with, or you simply have some need some information on any of our bridge products: LeBridge Concrete, LeBridge Steel, OpenBridge Modular, and RM Bridge.
Sorry, I just put an email on the screen.
Yes, yes, thanks, Shin.
Mhm.
Let's just give them a minute or two to note
Sure.
these email addresses and we can then conclude the meeting. All right, I think that is it, guys. Again, one more time, thank you for attending, and we'll see you in about a month.
All right, thank you, everybody. Thank you, Shiri.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.